In this presentation, we'll learn how to read tables and graphs depicting univariate and bivariate distributions. With univariate analysis, you're conducting a statistical analysis of one variable at a time. So for example, you would only be analyzing age, or you would only be analyzing race. This looks different depending on whether you're examining nominal, ordinal, or ratio scale levels of measurement in your variables. Pause the presentation and see if you remember the definition of these three types of measurement. Let's take a look at nominal first. Nominal levels of measurement are categories. They're represented in categories. So for example, a list of religious options. Ordinal scale are variables that are represented in rank order list of categories. So they're also a category, but they are in rank order. So for example, a Likert scale asking how much you agree on a particular issue. Ratio are variables that are represented as numbers, for example, income. In nominal and ordinal scale variables, you present data in frequency distributions, meaning the number of cases in each variable category. So for example, one variable asking for respondents' religious background would have the options of Christian, Jewish, Buddhist, and so on. Here we would present the data in frequency, so the number of cases within each category. So for example, 247 million Christians, 5 million Jewish, and so on. You can also present the data as percentage distributions. This means that it's the number of cases in each category divided by the total number of cases for the whole survey. So here you would present it in percentages: 78% Christian, 1.7% Jewish, and so on. In a ratio scale variable, you present the mean or average. Let's look at an example of each. This is a table representing a univariate analysis of frequency distribution of race and ethnicity. Pause the presentation and see if you can determine why this is a univariate analysis and how you can tell that it's presenting frequency distribution, meaning the number of cases. So we know that it's a univariate analysis because it's presenting results from only one variable, race and ethnicity. The list, white, African American, Asian American, and so on, are the response options or variable options within the one variable of race and ethnicity. So this is a univariate analysis. We know that it's showing us frequency, the number of cases, because it tells us here at the top. This is also an example of a nominal level of measurement. So the options are offered in categories, but they're not in rank order. This is a table also representing a univariate analysis, but of a percentage distribution. Here at the top, the table tells us it's a percentage distribution. Remember that to find a percentage, you have to divide the number of cases in each category by the total number of cases. To find the percentage of Asian American respondents, we would take the number of cases who labeled themselves as Asian American, so 29, and divide it by the total number of responses, 753. I got these numbers from the previous table that showed frequency distributions. So this would give us a 3.9% of Asian American respondents. Let's take a look now at bivariate analysis. So as you might guess, a bivariate analysis is a statistical analysis between two or more variables. So bivariate analysis is where you begin to test your hypotheses. The univariate analysis is much more descriptive, while bivariate is more inferential, if you'll remember those terms from the previous presentation. So in your hypothesis, you're asking what's the relationship between two variables. does the independent variable result in change in the dependent variable? So you present nominal and ordinal scale variables in tables called cross-tabulations. In cross-tabulations, rows represent one variable, usually the dependent variable, and columns represent another variable, usually the independent variable. So we'll be looking only at nominal and ordinal scale variables since ratio scale variables require statistical analysis software. So just ignore that one for now. Here's an example of a cross-tabulation. See that we are being shown the relationship between two variables, attitude toward gun control and sex of the respondent. What is the dependent variable here? And what is the independent variable? Pause the presentation to find these answers. So the dependent variable is attitude toward gun control. You could have found that by logic. It's impossible for one's attitude toward gun control to have an effect on one's sex. But you could also have found it because the data from the dependent variable is usually presented in the rows, favor and oppose. The independent variable is sex. This you could have found because the data from the independent variable is usually reported in the columns, here male and female. In a cross-tabulation table, each cell reveals a bivariate distribution for each variable response. So for example, this cell tells us that 79% of women favor gun control. So this is telling us the distribution of a variable response in two variables. First, all of the females within the variable of sex who responded has been in favor of the variable attitude toward gun control. So remember that the bivariate analysis is inferential, meaning that we're seeking answers to our hypothesis. If our hypothesis was that women were more likely to support gun control, what would be our conclusion? Our conclusion would be that our hypothesis was correct. As we see here, more women support gun control, suggesting that sex has an effect on attitude toward gun control. So in summary, a univariate analysis is an analysis from one variable. In nominal and ordinal scale variables, you can report it as a frequency, the number of cases, or a percentage distribution for each variable category. Ratio scale are reported as a mean or average. You can see examples of this in tables 12.2 and 12.3. Bivariate analysis analyzes data from two variables. This is often reported using a cross-tabulation table for nominal and ordinal scale variables. You report the dependent variable in the rows and the independent variables in columns. You can see examples of these in tables 12.4 and 12.5 in your textbook. For this week's discussion board and the final exam, you'll be creating a univariate and a bivariate tables. Your univariate table could look something like this. Note that this looks different from the earlier examples. What I've done is included multiple univariate analyses in one table. For the discussion board, you'll present data from three variables. And so you can use this as a model to represent your data from, for example, age, sex, family status, or any other variable that you think is important. I'll let you decide whether to use frequency or percentages. This is a table that can be used as a model for your bivariate analysis. You'll see here that the dependent variable is presented in the rows and the independent variable is presented in the columns. Of course, you might have more columns depending on how many responses you have in your independent variable. This is the end of your presentation.